let's derive the derivatives for arc cosine of x and arc tangent of x. Remember, I could ask this on an exam, so you are responsible for knowing this. The derivations are analogous to the derivation for arc sine. So if you really understand this procedure, then you should be able to do these just fine. So let's do the proof for arc cosine first. Okay, so we're going to say let y equal arc cosine of x. So we're trying to find dy over dx. But of course, we don't know anything about dy over dx. We don't know anything about arc cosine. What we can do is we can apply cosine to both sides and get that cosine of y equals x, right? Because cosine of arc cosine of x is just x. So the big thing is we're going to implicitly differentiate, and we're going to get, what is that, negative sine of y dy over dx, or y prime, equals 1. Right, which implies that dy over dx equals 1 over negative sine of y. And now perhaps we would draw a little triangle, a right triangle going on right here. And let's see, if cosine of y equals x, guess that means that we have this, right? I'm looking right here. And I guess that means this is going to be 1 minus square root of 1 minus x squared, right? And so I guess going back here, this is 1 over negative the square root of 1 minus x squared, which explains where we get our answer. Okay. Let's show it for arctangent. Same sort of thing. So now we're going to let y equal arctangent of x. And as you might expect, we would say tangent of y equals x. Okay? So we implicitly differentiate. What are we going to get? Secant squared of y dy over dx, or y prime, equals 1. And of course, that implies that dy over dx equals 1 over secant squared of y. And perhaps the squared suggests why we're not going to have a square root in this derivative. Right, but again, we can draw our little right triangle. Again, we have our angle here, and we know that tangent of y is x. So we can consider the triangle with sides x and 1. And I guess that means the hypotenuse has length square root of 1 squared plus x squared. Right, square root of that, right? And then if we look at secant squared, that's going to be hypotenuse over adjacent quantity squared. And that will give us this. Okay? So there you have it. Derivatives of arc cosine and arc tangent. So you see why I'm making you responsible for these in the exam. They're very short, and they're nice, quick little applications of implicit differentiation.